Good morning, good afternoon, good evening, wherever you're watching this from. This is Cornelius Lubinda with another video. Alright, so we are continuing on the chain rule examples. This is example number 4. In this video, we'll delve into how to answer example number 4. Alright, let's get on with the video and answer the question. Question 4 reads, given that L is equal to 1, you divide by A plus BX, and that L is equal to 1 and the L dx is equal to 3, when x is equal to 1, find the values of A and B. Alright, so let's write the function. So we have the function L is equal to 1, you divide by A plus BX. And then here they are saying that L is equal to 1, and the L dx is equal to 3 when x is equal to 1. If you want to find the values of A and B, it means we need to form two equations where we can find the values of A and B. Now what can we do here? Since they're saying that L is equal to 1 and they're also saying in the same sentence that x is equal to 1, we'll substitute it in this equation. Okay, to form the first, in this function, we'll substitute L is equal to 1 and x is equal to 1 in this function to form a new equation. We'll say when L is equal to 1, x is equal to 1. So 1 is equal to 1, you divide by A plus B multiplied by 1. 1 is equal to 1, you divide by A plus B. Then now you cross multiply. A plus B is equal to 1. A plus B is equal to 1. This is your equation 1. Okay, that's easy to find your equation 1. Then for equation 2, they are saying that the L dx is equal to 3 when x is equal to 1. Differentiating this one, you have to use the chain rule. But the faster way is using the method for the core. So in this video, I'm going to explain how we use that method. Okay? So I'm not changing anything, I'm just writing L in another way. A plus bx to the power negative 1. What have I done? I've taken this up right there so that it can become in a linear form in that way, because we cannot differentiate it when it's in this fractional form like that. So I just took it up, I haven't changed anything. Okay, this is the same as that. Then we differentiate this. We're going to have the L dx is equal to negative 1 multiplied by the number in front of the bracket here. It's an invisible 1, so negative 1 multiplied by that 1 will be negative 1. Then this in the brackets, this expression A plus bx is called the core. We keep it the same to be A plus bx, like that. Then we close the bracket. There's the power negative 1. The negative 1 will lose 1, it will become power negative 2. Then after that we differentiate the core. The derivative of A, since we know that A is has a certain value, so it's a constant. A is not a variable because at a certain value it's a constant. Okay? A constant just simply means it's a number, and the derivative of a number is 0. So the derivative of A is 0. Derivative of bx is going to be b. Why? Because bx is an invisible power 1 here. When the power 1 is multiplied by b, you're going to have b. And then the power 1 there will lose 1. Then you're going to have b x to the power 0. Any number the power 0 simply be 1, and your answer is b. That's why I'm saying that the derivative here of the core is just simply positive b, like that. Then we can just clean up to create space. Okay? And then to proceed, we can take this expression here, the core, we can take it down so we can make the power positive. So your dl dx will be equal to negative b divided by a plus bx raised to the power positive 2. In that way, after writing it L dx like that, so this is your final answer for the L dx. Now we go back to information. When the L dx is equal to 3, x is equal to 1. Okay. So we'll say dl dx is equal to 3 when x is equal to 1. Okay. So in this same LDX, we're just going to substitute 1, okay, where there is x, and then we'll say this here is equal to 3. What do I mean? I mean negative b divided by a plus b. We're saying x is 1, okay, then we close the bracket like that, or the parentheses, and then say is equal to. So this is equal to 3, like that, okay. Then to proceed, we'll just simplify here. It will be negative b divided by a, of course here there's a power 2, sorry. So a plus b raised to the power 2 is equal to 3. Then when we reach this stage, we can write 3 like that. We divide by 1. Why am I dividing 3 by 1? I'm setting it up so that we can now cross multiply. When we cross multiply this, we're going to have 3 multiplied by a plus b squared is equal to negative b. And this is your equation 2. So 3 multiplied by a plus a b squared is equal to negative b. That's your equation 2. So 3 multiplied by a plus b squared is equal to negative b, equation 2. Okay, so if you see these equations, we cannot solve this equation by using elimination method. Because we have a plus b is equal to 1, the best method to use in this case would be substitution. So we substitute either a or b in this second equation. So for me, my choice, I'm going to pick a, okay? I'm going to pick a. So I'm going to say let a be equal to, so this b will go to the other side, 1 minus b. Let a be equal to 1 minus b in equation 2. So 3 you multiply by a is 1 minus b, so we have 1 minus b like that plus b, as we can see. I hope you can see that. So where there was a in this equation, I've put 1 minus b, and then I've said plus b squared, the same equation, is equal to negative b. So here, if we want to proceed, the next thing to do is we say 3 you multiply by, here if you check, the negative b and the positive b can cancel out to just leave us with 3 times 1 squared is equal to negative b. 1 squared is simply 1, so it's equal to negative b. 3 times 1 is 3, it's equal to negative b. We divide both sides by a negative 1 to get rid of the negative that is with the b. Therefore, we'll say b is equal to negative 1 into positive 3 is negative 3. So b is equal to negative 3. So say let b be equal to negative 3 in equation 1, which will say a is equal to 1 minus b, okay? So I'm just getting this equation here, 1 minus b, which is a negative 3. When you have a negative number, always remember to put it in brackets or the parentheses. So you're going to say 1 minus negative 3, which will be 1 plus 3. A is equal to 4. Therefore, A is equal to 4. B is equal to negative 3. That's how you conclude, and that would be your final answer for this particular question. This marks the end of this video. Thank you so much for watching. This has been Cornelius with another video, and bye-bye.